Okay, this is 4.4 of algebra. So we're going to look now at graphing functions. So let's just skip down to our got it problem down here and graph this equation, 1/2 times x minus 1. So I'm going to make a table with my x and my y equals 1/2 x minus 1. And then I'll write my ordered pairs. So, plugging in about like 3 or 4 points is always good. I'll start with plugging in -1. That would be 1/2 times -1 minus 1. 1/2 times -1 would be -1/2. Minus 1 would be -1.5. Oops, that's a negative. And so my point is -1, -1.5. And then I'll plug in 0. So 1/2 times 0 minus 1. 1/2 times 0 is just 0, so this is just -1. And then I'll plug in 1. 1/2 times 1 minus 1. Well, 1/2 times 1 is 1/2. Minus 1 is going to be -1/2 or -0.5. Let's fill in our points. Let's just plug in 2 anyway. 1/2 times 2 minus 1. 1/2 times 2 is going to be 1 minus 1 is 0. So this is the point 2, 0. Okay, and then I'm going to graph it. So the smallest that my x is -1, and the smallest that my y is -1.5. So this is going to be negative, we'll do it in decimals, -1/2, -1, -1.5. So I went, I'm going up by halves on my y, and then I'll just go by ones on my x. So that'll be -1. I'll graph in a different color so we don't mix it up. Okay, so I've got a point at -1, -1.5. So right there over the negative sign. 0 and -1. Oh, that's a bad point. Here we go. 1 and 0 and -1. Oh, let's correct my ordered pair over here. I forgot my negative sign. There we go. So 1 and -0.5, and 2 and 0. Approximately like that. Okay, graphing real-world functions. We're going to skip to our got it problem. But the main thing we need to remember in real-world functions is that it doesn't always make sense for the line to go on forever. In this case, they're talking about a concrete mixer truck, and it has a capacity of 200 cubic feet of cement. So I can't have 500 cubic feet of cement. That's not going to fit. So my maximum that I can plug in is 200 cubic feet for my X, or in this case, my C. The other thing we need to remember is that it doesn't make sense to have negative cubic feet. So it's only positive, and it stops when we get to 200. Okay, the function rule W equals 8g plus 700 represents the total weight W in pounds of a spot that contains g gallons of water. What is a reasonable graph of the function rule given that the capacity of the spot is 250 gallons? So the biggest that I'm going to plug in for g is 250. The other thing is that I can't have negative gallons, so I'm going to start at 0. Oops. So let's make a table here. X. Well, actually, I'm not going to use X. In this case, my G is my X. Whatever variable is alone, that's your Y. So in this case, G then is my X. So X in parentheses, G. And W equals 8G plus 700. So that's my Y. And so my ordered pair is going to be G, comma, W. Okay, so I'm going to start by plugging in 0. 8 times 0 plus 700 is just going to be 700. So this is the point 0, 700. And then I'm just going to pick a few numbers until we get to 250. So why don't we plug in 50. 8 times 50. That's supposed to be a 50. 8 times 50 plus 700. That'll give me 400 plus 700, which is 1,100. So this is 50, comma, 1,100. Then let's plug in, how about, well, we'll do 150. I'm choosing numbers that end in 50 because that's what I'm going to go up on my graph with. So you don't have to choose numbers that end in 50 or that end in zeros. That would work too, but it'll just be nicer for graphing my points. 8 times 150 plus 700. 8 times 150 is 1,200. So when I add 700, I get 1,900. So 150, comma, 1,900. And finally, I'll plug in 250 because that's my maximum. So 8 times 250 plus 700. 8 times 250 is 2,000 plus the 700 gives me 2,700. So 250, comma, 2,700. Okay, and now I'll draw my graph. Okay, so down here I'm going to go up by 50s. Here, maybe I'll skip 2 just so there's more room. 50, 100, 150, 200, 250. And then I need to get all the way up to 2,700, so I'm going to try going up by 300s. So 300, 600, 900, 1,200, 1,500, 1,800, 2,100, 2,400, 2,700. Oh, I had plenty of room. Probably could have gone up with 200s maybe. But, and then I'll plot my points. So 0 goes with 700. Let me switch colors. That's about right there. 50 goes with 1,100. That's about right there. 150 goes with 1,900. It's about right there. And then 250 goes with 2,700, and that is right there. And I can try to connect. Oh, that was bad. I could try to connect those in a straight line. There we go. And that's what my graph would look like. Okay, so when we're graphing, there's 2 different ways we can graph. It's called a continuous graph, and that's where we have our line, or a discrete graph where we just keep the points. So when we have the line, that means any point on this line I can choose will be a solution. It'll make sense. Whereas with my points, I can only choose a point, and that makes sense. So if you think about like selling CDs, I can't sell a half of a CD, so continuous graph wouldn't make sense. But a discrete graph then would make sense. Or if I'm talking about buying gas at the gas station, I can buy half a gallon of gas, so that's okay. So I would use continuous instead of discrete, because it's not that I can only buy like 1 gallon, 2 gallon, 3 gallon, right? You choose how much you want. You can get 2.73 gallons. So we got this great looking dude here in our book that's selling wheels of cheese. So it's just showing the example. Over here we've got gallons of milk, and we've got weight in ounces of cheese. This is one where it's okay to have 2.3 ounces of cheese. It's okay to have 1.5 gallons of milk. So we have a continuous graph here. And this one, they're selling whole wheels of cheese. They won't cut it for you. You can't buy half a wheel of cheese, so you need to use the points. And so there's a point at 1, there's a point at 2, there's a point at 3, there's a point at 4. Okay, so we are going to graph our own here. So let's look at our first situation. The amount of water, W, in a wading pool in gallons depends on the amount of time, T, in minutes. The wading pool has been filling. As related by the function rule, W equals 3T. Okay, so can I have negative minutes? No. So I'm going to start at 0. So T is my X. I've got W equals 3T. My points are going to be T comma W. Okay, I'm going to start by plugging in 0. So 3 times 0, that's just 0. So this is the point 0, 0. I'll plug in 2. I'm just choosing numbers here. 3 times 2 is 6. So this is the point 2 comma 6. And how about 5? 3 times 5 is 15. So this is the point 5, 15. And I'll graph it. So 1, 2, 3, 4, 5, 6. I need to go up to 15, so let's go up by 3s. 3, 6, 9, 12, 15. Hey, perfect fit. Okay, so I've got a point at 0, 0. That's right there. I've got a point at 2, 6. And I've got a point at 5, 15. Can I have 1.5 minutes? Sure. And can I have 2.5 gallons? Yeah. So this is going to be a continuous graph. So I'm going to connect my lines. Connect my points in a line. Let's look at B. It says the cost C for baseball tickets in dollars depends on the number N of tickets bought, as related by the function C equals 16N. So I'll make a table. N comma C. So I can't buy negative tickets, so I'm going to start with 0. 16 times 0 is just 0, so this is the point 0, 0. We'll buy 3. 16 times 3 is 48. So this is the point 3, 48. And let's plug in 5. 16 times 5 is 80. So 580. Draw my graph in. I'm going to go up by 10s for my y, because I got to get all the way up to 80. Oh, I need a little bit more room even. And I'll just go up by 1s on the bottom. Okay, so I've got the point 0, 0. That's right there. Remember my origin, that's another word for it. 348. So that's about right there. And 5 goes with 80 right there. Okay, do I connect this one? No, because I can't buy 1.5 tickets, right? That doesn't make sense. Yes, I can have $50.23. So that would make sense, but the fact that tickets doesn't make sense, then we keep it discrete. We don't connect the dots. So that would be my graph. Okay, so graphing nonlinear functions. You do it exactly the same. You just plug in numbers. It's good to keep in mind, though, that an absolute value function looks like this. The general one looks like that. But when you have x squared, you're going to have a graph like that. And when you have x to the third, you're going to have a graph like this. So this is the absolute value of x. This is x squared. This is x to the third. So we need to make sure that we're taking points that are, a few points that are negative and a few points that are positive, so that we make sure that we get the whole picture of the graph, right? Because if I only took the positive numbers over here, it would look like a straight line. If I forget the negatives, then I'm not going to get this whole side of the graph. And there's your homework.